In this video, I will review the problems that were presented as examples in the reading summary so that you can check your work. For example 1, you're given that you have a regular dodecagon, which is a 10-sided polygon, and you're asked to find the measurement of each one of the angles in that dodecagon. Well, the first thing is, since it is a regular dodecagon, all the angles have to have the same measurement. That's part of being a regular polygon. I mean, all the sides are going to be congruent too, but I'm only concerned with angle measurement in this problem. So, I don't have to spend much time with that. Now, how am I going to find what their measurements are? Well, I'm going to look at the sum of the angle measures for this dodecagon. Now, there's two ways I can express this. Obviously, since there are 10 angles in this dodecagon, they're all the same size, then the sum of the angles should be 10 times whatever the measurement of x is here. We also have a rule that says the sum of the measures of interior angles for a polygon, an n-sided polygon, is given by the formula n minus 2 times 180 degrees. That means that the sum of the angles for this dodecagon can also be found by doing 10 minus 2, because there's 10 sides, times 180 degrees. These two are both representing sums of the angle measurements, so they should be equal to each other. So that means that 10x would equal 8 times 120 degrees, because that's going to be 8 here, which would be 1,440 degrees. Therefore, solving for x would be 144 degrees, and x is what I let be the angle measurements for each one of these angles. So each angle is 144 degrees. For example 2, you were given that these two triangles, ABC and DEF, are similar triangles, and you were asked to find these various measurements. Now, there's two facts about similar triangles that I'm going to make use of here. The first of which is that corresponding angles are congruent. So I got to figure out which ones are corresponding angles. Now, typically, if they're telling you specifically that ABC and DEF are similar triangles, that means that A would be corresponding to D, B would be corresponding to E, C would be corresponding to F. But sometimes, if they're not very careful about that, it could be a little bit on the sloppier side. So you want to make sure that that's the way it's still being done, because that's the way it's supposed to be done, but sometimes the way it's supposed to be done and how it was actually carried through may not be the same. So let's use some other rules and make sure that this is the case, because knowing which angles are corresponding is going to let me know which angle should be congruent, and therefore let me figure out measurements of angles, and then eventually figure out the sides. So in this triangle down here, I know two of the three angles, and I know that they should total up to be 180 degrees. So if I take 19 degrees plus 135 degrees, I get 154 degrees, plus whatever the measurement of angle A is, should total 180. That means that the measurement of angle A should be 26 degrees. So I now know this is 26 degrees. When I look at, what's going on here, as far as knowing, which angles should be corresponding to each other, there's another fact that was discussed, is that the smallest angle should be opposite the shortest side, the largest angle opposite the longest side, that so forth and so on. I know that AC should be the smallest side on this triangle, which means that, that angle E is the 19-degree angle because it's opposite a side smaller than the 14-inch side. So I know that this would probably be what the smallest side is on this one. So that lets me know that angle E is 19 degrees, angle D is 26 degrees, because angle D is what corresponds to angle A. E corresponds with B, C corresponds with F, much like the names do show already. So the naming convention is also upheld on this, the way it's been set up. So, but I also more importantly now know that the measure of angle D and the measure of angle E are 26 degrees and 19 degrees respectively. Now I'm going to start focusing on the sides. Once I know what the angle measurements are, I know which sides would be corresponding to each other. For instance, the 33-inch side and DE correspond to each other on these two triangles because they're both opposite the 135-degree angle. AC and DF correspond to each other because they're both opposite the 19-degree angle. And of course, EF and BC correspond to each other because they're both opposite the 26-degree angle in their triangles. So when I start setting up these ratios, that means that 33 over DE, the measurement of DE, AC over 10, and I'm going from bigger triangle to smaller, should be basically this ratio of BC over EF, or 21 over 14. So I do have two sides. I mean, I have a pair of corresponding sides both known. That's the same thing as a 3/2 ratio, which means that 33 over DE should equal 3/2. AC over 10 should equal 3/2. There's different ways you can approach the solution to this. I'm going to show a more basic one in this one. When I look at 3 and 33 in this first one, I notice that to go from 3 to 33 and keep the same ratio, I multiplied the top by 11, which means the bottom would have to be multiplied by 11 to make sure that these two were the same ratio. So DE would be 2 times 11. DE would be 22 inches. And very similarly, to go from 2 to 10, I would multiply by 5, which means to keep the ratio of the same value, I'd multiply the top by 5. So AC would be 3 times 5, or 15. And that's how I get those values. For the silo problem, when you have these two things, now we're making a couple of assumptions here. You have this, you're going to have two right triangles. This one here, made by the person, this length here, and this, imaginary line going from the sun to the top of the shadows of, both of these people, the person in the silo, I should say. We're going to assume that the person standing upright is in a manner that's perpendicular to the ground, and we're going to assume that the silo was built perpendicular to the ground. Slanted people and slanted silos, both don't tend to fall over, so we're going to assume that, that they're upright. So basically, I have two right triangles where, I have the 90-degree angle, of course, it's both right triangles. If they share this angle, that means that this angle up here, this angle up here would have to be congruent. And since in a triangle, if all three angles are congruent, it's automatically going to be similar triangles to each other. So I do have similar triangles here. That's the important part. So when I look at this triangle here, made by the person and his shadow, I have this triangle here. When I look at the triangle with the silo and its shadow, I have this triangle here. And I have the angles on here marked so I know which angles are corresponding, which helps me figure out which sides are corresponding. Because the corresponding sides of these two triangles would be H and 6, along with 105 and 9. So when I set up this equation that, H over 6 would be 105 over 9. And I'm getting ahead of myself here. So now, going from 6 to 9, it's not as easily done with integer multiplication because no integer would work. Multiplying a number to get to 9 from 6, maybe something you would struggle with because it would involve fractions at that point. So there's another method that was often taught about, which is that we could cross multiply in order to solve this, which means I would do h times 9 to get 9h, and 105 times 6 to get 630, which means that 9h would equal 630. Dividing both sides by 9, I would get that h is 70 feet. So based on this calculation, the silo is 70 feet tall. For the last example, you were given that these two triangles are congruent. And what's even nice about them, usually if you have congruent triangles, and the first one's ABC, the other one has primes, you know that A prime should correspond to A, B prime could correspond to B, C prime would correspond with C. It makes it a little easier to discern which angles are corresponding, which sides are corresponding. Looking at just the information I have between the two figures, if they're congruent, I know that A prime should be 31 degrees because A is 31 degrees. That's angle A prime. I know that AB is 33 because A prime B prime is 33. A prime C prime is 34 because AC was 34. So forth and so on. And that lets me fill in the vast majority of this information because I already have it labeled in the figures. Where I run into a little bit of difficulty is with angles C and C prime, which they call ACB and A prime C prime B. You really didn't have to go with the three-letter designations here, mostly because of the fact that these are two separate triangles. Each angle has only one letter as the letter at the vertex. So angle B, there's only one angle B in this figure. So it's whenever I have multiple angles with the same vertex, that's when I have to definitely use the three-letter naming system. But in any case, these two angles, C and C prime, should be congruent to each other. I just don't know what they are. Going back to one of the other rules we talked about, the measurement of angle C, the measurement of angle A, and the measurement of angle B should total 180 degrees. So the sum of those three angle measurements would equal 180. I already know two of them. I know 31 and I know 78, which means that the measurement of angle C plus 109 degrees would equal 180 degrees. Which means that the measurement of angle C, or ACB is one of the other names you could give it, is 71 degrees. And since C prime would be congruent because it's a corresponding angle, it's also going to be 71 degrees, so both of these are 71 degrees. And that is the end of this video. If you have any further questions, please make sure to reach out and ask me about it. Until next time, have a good day.